Hello guys, welcome to today's session. Today's session, we're going to continue with our variance analysis. So if you're attending the class for the first time, I divided variance into 3 sessions: planning and operational variance, mix and yield variance, and sales mix and quantity variance. So we have completed planning and operational variance. If you have any question, concern with regards to that topic, you can always reach me. If you have a question you want me to clear for you, you can always reach me on that one. So today, we're going to start mix and yield variance. So let me share my screen. Okay. Today, we're going to start with material mix and yield variance. So what this is telling us about, we all know variance is the difference between what we budgeted, what our standard costs are, and what's the actual result. So the difference between what we budgeted, the standard cost, and the actual cost, what we refer to as variance, okay? What's material mix variance? Why does we have material mix variance? This arises due to non-appropriate mixing of materials. Material mix variance arises due to non-appropriate mixing of material. What is that telling us about? For us to make a particular product, we are using different components of material to make one product. For instance, we want to make a bread. What do bread make? Yeah, we want to bake a bread. Baking a bread, we need flour. We need flour. We need sugar. We need salt. We need water. So these are just few components we need in making a bread, okay? So how much of flour do we need to make a particular quantity of bread? How much of sugar do we need? How much of salt? So can we put as much sugar as we want? Can we use as much salt? No, we have standard mix. We have a ratio of how we mix the bread. So the variance arises due to non-appropriate mixing of these materials. That arises to the mix variance. Okay? We'll see that as we go along. So what's the yield variance? The yield variance measures how much output was expected from the actual input. Yield variance is looking at the result, how much output was expected from actual input. Okay, what we inputted into the process. Let's say we input 4 cups of sugar and flour, 1 cup, salt, 1 cup, water, let's say 4 liters. So this is what we inputted. What is the output? So yield variance is looking at the output. Okay, so mix and yield variance is in summary telling about the quantity of material, the combination of material we use. Okay, so now if we have adverse mix variance, what's the meaning for adverse mix variance? Adverse mix variance indicate that expensive material was input more and cheaper material was input less. So we input more of expensive materials and less of cheaper materials. Of course, we'll have adverse variance, negative variance, adverse variance. But if the material we use, if we use more of cheaper material and less of expensive material, we'll have adverse variance. But remember, if we use too much of cheaper material, our yield variance will be negative. Our output will not get the quality that we wanted. We will have a lot of wastage as a result of what we inputted. So quality should not be compromised. Don't forget. Okay? So how do we calculate these variances? How do we calculate these variances? The mix variance and the yield variance. There's a formula, and the formula is a little bit tricky, but we'll break it down to see how it will be easy. Okay? So how do we calculate material mix variance? Material mix variance can be calculated by, the formula would be, I will start with projected quantity at actual mix, projected quantity at actual mix minus actual quantity at actual mix multiplied by standard price. I will use this formula to get my material mix variance. Projected quantity at actual mix minus actual quantity at actual mix multiplied by standard price. Don't worry. When we get to question, it will be easy. Just memorize this formula. You have to memorize this formula. And when we are solving a question, we'll break this formula down to be easy. Don't worry. So this is how I will get my material mix variance. How can I get my material yield variance? My material yield variance. I will get the material yield variance by projected quantity at standard mix minus projected quantity at actual mix multiplied by selling price. So this is how I'll get my yield variance. Okay? Okay, so this is how I'll get my material yield variance. Projected quantity, remember the budget is the same as the standard? Projected is the same as the standard. Projected quantity at standard mix minus projected quantity at actual mix multiplied by selling price. This is how I get my material yield variance. Okay, so now let's see how we can interpret these variances using the question we started. We started the question which we solved the section A, the analysis to interpret the variances already calculated. So we skip the B part for us to start the variance analysis. So now that we have the basic idea of mix and yield variance and we've learned the formula, so let's go back to the question and see how we can tackle the B part. Okay, so this was the question we started the other day, and crumble cakes, we've completed the A part of this question. Now let's look at the B. We skip the B part, waiting for the variance, yield, mix and yield variance concepts, learning the formula before we can start. The B part starts from here. In April 2009, the following data applied. Okay, so the following is a standard cost card for 1 cake. So to produce 1 cake, this is a standard cost card, not adjusted for the organic ingredients change. So this is the standard cost card to produce 1 cake. So when you have flour, egg, butter, sugar, total input is this one, normal loss 10%, standard weight of cake, 0.36. Okay, now this is the information we have. The budget for production and sales in April was 50,000. This is a budgeted production. Actual production and sales was 60,000. So we budgeted 50,000 cakes. We produced, the actual production was 60,000, okay, in a month, during which the following occurred. So for us to produce this 60,000 cake, this was the actual result. We actually used 5,700 kg of material to produce 60,000 cake. So these are the actual results: flour, egg, butter, sugar, and all the rest. All cake produced must weigh 0.36 kg, as this is what is advertised. Okay, so they're advertising that the cake weight 0.36 kg. So all cake, the output, the yield variance should make that standard. All cake should be weighed at that kg, because this is what was advertised. Required: A, calculate the material mix and yield variances for April. You are not required to make any comment on the performance of the managers. So in this one, we just have to calculate the material mix variance and calculate the material yield variance. No analysis. C, discuss independencies that might exist between material price and material yield variance. Because if the price is cheaper, we'll buy cheaper quality of material, we'll buy cheap material, right? Our yield variance will be negative. We will not get the output result we want to get. If we buy more quality material, then we'll get quality output. You get? So let's tackle let's try to understand the formula using this example. Okay, let me see what I can do here. Okay. So now let's analyze this question. Let's set the formula and we solve this question. Okay. So our A part, we are asked to calculate mix variance. Mix variance. Mix variance, we learned the formula already for mix variance. We learned the formula to be standard quantity at actual mix minus actual quantity at actual mix multiplied by the selling price. Okay, so this is the formula for mix variance. Standard quantity at actual mix minus actual quantity at actual mix multiplied by selling price. But you cannot see this information in the question. So what we do, let's set a table. This table will help you, trust me. So what I will have here on my first table, I will have the ingredients. I'll have the ingredients. My ingredients, I have flour, I have egg, I have butter, I have sugar. These are my ingredients. These are my ingredients. Okay. My first table. My second table, I will have my first formula, standard quantity at actual mix. Standard quantity at actual mix. Okay. My next table, I will have my actual quantity at actual mix. My next table will give me my standard price. Standard price. Standard price. Sorry. Standard price. Then from here, I will have my variance here. Variance per kg. And I will have my variance per dollar. Okay. So let's see. So now I will, so this is how I will set my table. You see the formula. We said that standard or budgeted quantity at standard mix minus budgeted quantity at actual mix multiplied by standard price. So I have a table for my ingredients. I have a table for my first part of the formula, standard quantity at actual mix. I have a table for my second formula, actual quantity at actual mix. I have a table for my standard price. And the difference between this standard quantity actual mix and actual quantity actual mix gives me my variance in kg. And when I multiply my variance in kg by standard price, I will have my variance in value. You understand? So that will give me the mix variance for each of the ingredients, and total the ingredients will give me the variance for this mix variance for this particular cake. Okay? So now let's go to the question. Before we go to the question, look at the formula. I will start with my actual quantity at actual mix. I already have that figure. That figure will always be given to you in the exam. Actual quantity at actual mix will always be given to you. So I will start with my actual result. Okay? So what's my actual quantity of actual mix? It's just the actual figures. So for flours, how much is my figure for flour? 5,700 kg. For flour, it's 5,700 kg. This is my actual for flour. For egg, it's 6,600. 6,600. And for butter, is 6,600. 6,600. And for sugar, is 4,578. 4,578. What this will give me? What's my total? So I'll total all of this. 5,700 plus 6,600 plus 6,600 plus 4,578. This will give me 23,478. 23,478. Okay, this is my first step. I will start with my actual result. My second step, my actual result should be equal to my standard quantity at actual mix. Remember, the first formula also need actual figures. So my second step will be my total for my actual quantity, actual mix, should be the same total for my standard quantity at actual mix. So the same total coming out 23,478. This is my second step. This is my second step. Okay, so my first step is to get my actual figures. My second step is to bring total to be equal. What's my third step? My third step now, I need my standard quantity at actual mix. Then I will go to my standard results. My standard results. So what are my standard results? My standard results says I need flour 0.4 kg of flour. That's a mix. 0.4 kg of flour, 0.10 kg of egg, and 0.10 kg of butter, 0.10 kg of sugar. That's my standard. Total inputs are how much? 0.4. That's my standard, right? 0.4. So my standard is 0.4, the mix. So now that's the total mix. Let me do the formula here. I will do this formula 1 and we'll take it. The mix here says for flour, I need 0.1 kg of flour, 0.10 kg of flour. And what's the total standard kg? Total standard kg is 0.4. 0.40. Multiply by the actual result, which is the total, which is 23,478. What this will give me? This will give me 0.10 divided by 0.4 multiplied by 23,478. This will give me 5,869.5. So this is my standard kg for flour. But if you notice, for flour, egg, butter, sugar, all is the same 0.1, 0.1, 0.1, 0.1. So I don't need to repeat all this formula. This is just a coincidence. It can be different. So you do for each ingredient. For the first ingredient is flour, I've done this one. Let me try it for egg. egg, I will take the kg, the standard kg of egg, which is 0.10, divide by total kg 0.40. You get? Multiply by a total of 23,478. So the 23,478 is constant for all, but the kg might be different. For this question, just a coincidence, the kg is the same. So we just use the same figure of this 5867.5. Okay, so we're filling these figures into the table. 5869.5. When we total all of this, will equals to 23,478. That's my second step. My third step, I bring my standard price. What are my standard price? My standard price, I have $0.12 per kg. That's my standard price for flour. 0.12. This is my standard price. The next one, 0.70. The next one is 1.70. That's my standard price, and 0.50. These are my standard price. So what is the variance? The variance is in kg first. The variance in kg is the difference between the standard quantity at actual mix minus actual quantity at actual mix. So I'll do this 5869.5 minus 5700. This gives me 169.5. 169.5. 169.5. Okay. So that is my difference. 169.5. So 169.5 multiplied by the selling price for that product, flour, that gives me the variance in value. Okay. So I will do this right away. So the variance kg, but what's my standard price? The formula said standard quantity at actual mix minus actual quantity at actual mix multiplied by standard price. So now I've gotten this standard quantity actual mix, actual quantity actual mix. I've gotten the answer to be 169.5. Multiply this by the standard price. The standard price for flour is 0.12. I'll just multiply that by 0.12. This will give me my variance of 20.34. And this is a favorable variance. This is a favorable variance. Our standard cost was 5,869, and our actual result was 5,7. So the actual result was less than what we projected. So it's a favorable variance. Let's take the next one. The next one is 5,869.5 minus 6,600. This will give me my variance of 730.5. 730.5. Multiplied by standard price, which is how much? 0.7. This will give me 511.35. This will be an adverse variance. Adverse variance, we budgeted 5,869. Our actual result was 6,600. Our actual result. So it's become an adverse variance. Okay. So what is the next one? Next one, 5,869.5 minus 6,600. The same. It's the same thing. 730.5 multiplied by the standard price, which is 1.7. This gives me 1241.85. Adverse. It's an adverse variance as well. We budgeted 5,869.5. Our actual result was 6,600. That's an adverse variance of 730.5 multiplied by 1.7. That gives me 1241.85. Adverse variance. And the last one, 5,869.5 minus 4,578. This gives me 1241.85. 91.5 multiplied by standard price of 0.5. This gives me 645.75. This is going to be a favorable variance. So these are my variances. I have 20.34 favorable, 511.35 adverse, 1241.85 adverse, and 645.75 favorable. What is my total variance? Total variance, we have some positive and negative. So we add all of it. So this plus so my variance, total variance now would be 1087.11. Total variance will be adverse. So this is my material mix variance. My material mix variance is 1087.11 adverse variance. Okay. I hope this makes sense, but don't worry, this is the first example. We'll do 2 to 3 questions on mix and yield variance. By the time we get to the second example, it will be flow. Okay, so this is our material mix variance. So let's go for the yield variance. Material yield variance. We'll set the formula as projected quantity at actual mix. No, sorry, projected quantity at standard mix minus projected quantity at actual mix multiplied by standard price. If you notice, when we did our first calculation, the mix variance, we have this same formula coming up. This same formula coming up. The same one coming up. The same one coming up. Remember? Yeah. When we did the first one, that same one comes up. This projected quantity at actual mix. It comes up. Okay. So this is the same with this one, standard quantity at actual mix. Okay. So we just bring that figure when we do the table because it repeats. So we set the same table for this one. We set the same table for this one. Bring in our ingredients. We have flour, we have egg, we have butter, and we have sugar. These are our ingredients. On my first table, I'll bring my standard quantity at budgeted quantity at standard mix. So I'll bring my projected quantity at standard mix. And I'll bring my projected quantity at actual mix. Okay, and I'll have my standard price, or I bring my variance here. Variance in kg. And I'll bring my standard price and variance in dollar term. This is my table. So because I have calculated the first one, I have the answers already to that first one, which is the answers is 5869.5 for which is my standard quantity at actual mix, and it's the same for all of them. I'll just bring this answer 5869.5. For this one, I'm not worried about the total. For yield variance, we don't need the total. Total should not agree. As in the previous mixed variance, I worry about total here and total here. For this one, it's not necessary. Doesn't important. Okay. Now, what is my standard quantity at standard mix? Comes to the question. My standard kg is 0.1 kg to produce 60,000 units. Actual production. We'll learn this from my first class with you on the planning and operational variance, right? When we are calculating the price variance, usage variances. We need the kg, the standard kg to the actual production. So it is 0.1 for flour, multiplied the actual production was 60,000. Our actual production was 60,000. So this gives me 6,000. Again, it's just unfortunate here. We have all the standard be the same, 0.1, 0.1, 0.1, 0.1. So if we have different standard, which normally is the case, so we do same for egg, 0.10 for egg, multiplied by actual quantity. Sugar, butter, same, we multiply all. But for this one, since we have the same standard, which is 0.1, multiplied by actual quantity, which is 60,000, so our answer will be 6,000. So our projected quantity at standard mix will be 6,000 for the first one, 6,000 for the second one, 6,000 for the third, and 6,000 for sugar. Like I said, we don't need the total. Okay. Now I need my variance in kg. My variance in kg has to be the same, which is 6,000 minus 5869.5. This will give me 130.5, 130.5, 130.5, 130.5, 130.5 will bring my standard price. My standard price, I have 0.12, 0.70, 1.70, and 0.50. Okay, so we multiply the variance in kg, multiply by standard price. So multiply by 0.5. For this one, I have 62.25. What will this variance be? We budgeted 6,000. Our budgeted and actual is how much? 5.8. So this will be favorable. Favorable. So 130.5 multiplied by 1.7. This will give me 221.85. 221.85 favorable. Next one, 130.5 multiplied by 0.7. This will give me 91.35 favorable. And 130.5 multiplied by 0.12. This will give me 15.66 favorable. So my total yield variance now would be 391.11 favorable. This is my yield variance. So we have our material mix variance and we have our material yield variance. So this is how we calculate mix and yield variance. Thank you. We'll solve the next question in our next class. Okay, see you later. Bye-bye. Practice this formula. Get the formula. If you don't understand, the video will be available. You can pause the video at any time and watch and calculate with me. Then you get it right. Okay, see you in the next question. Bye-bye.